Hey guys, this is Keanu again. This is going to be episode 4 of my high school physics work calculations, explanations, that kind of stuff. So today we'll be focusing on work. You have the normal formula: work equals force times distance. Later on, we will be talking about different forces and things related to that. But for now, we'll just be working on work. Ironically, working on work. So obviously that's the formula. So where you have work, or W is for work, which is in joules. Joules. You have your force in newtons and distance in meters. So, and this is normal. That's basically how you will always get these, at least like I said in acceleration and velocity for here in Canada. So because then it's Newton meters. A joule is a Newton meter. If you ever think about the units, really, a joule equals a Newton meter. And Newton is also a kilogram meter, or kilogram meter over second squared. So which means you actually then have a joule equals kilogram meter squared over second squared. So that makes sense, I think. I don't know. That actually wasn't something I was planning to put in here. Anyways. So, if you can read this, for the work to be done on an object, there must be 3 conditions that must be met. There must be movement, so you're moving it over. There must be movement, so you're moving it. So you're putting energy into it. That's something else I'm going to get into later, is your work is actually going to have something to do with energy input and output. So what you're putting out and what you're getting back. What you're getting back is the work, I think. No, never mind. I will relate work back to energy at a later point. There must be an applied force, obviously a force. It's moving, so there's a distance. And the force and the distance the object travel must be in the same direction. So in this, you are never, ever, ever, as far as I remember, going to get, well, you might get a vector. Well, you're never going to get these two as vectors that are different. So you're never going to get a north force and a south distance. You're never going to get a west force and an east distance. You're never, ever going to get that. They have to be in the same direction. So that's the basics of it. This hopefully should be a quicker, easier one, just because I only have 2 examples and it's not hard to manipulate. So we'll just start on the examples. A tugboat is towing a tanker through a canal using a tow rope. Calculate the work done by the tugboat. Oh, wow. Well, I can just go by it. Calculate the work done by the tugboat if it applies an average horizontal force of 6.50 times 10 to the 3rd newtons on the tow rope while towing the tanker through horizontal distance of 150 meters. I actually totally, oh god damn it, it's been a really bad video so far. So this is a very simple work equation. So automatically you can just go, okay, work equals force times distance. So you then have an average horizontal force of 6.5 times 10 to the 3 newtons. That goes back to my scientific notation video, which I'll put notation right about here. On the tow rope while towing the tanker through a horizontal distance of 150 meters. Pretty nice and simple. So obviously it's just plug your numbers in. 6.50 times 10 to the 3 newtons times 150 meters. And just do that on 6.5. Oops, I totally forgot to find out where that button is on this. Times 10 over 3. So that 6.5 times 10 to the 3 multiplied by 150. So, since we only want 3 significant digits, because you have 3 here and 3 here, and you're multiplying, like I said, check back on the scientific notation video if you don't understand that. And so what you're going to get is you're going to get 9.75 times 10 to the 5 joules. Okay. There you go. Same answer I got right there, and I got it right before. So it should be right now. If it's not, then I think there's a problem. So I only have 2 examples today, so it should be nice and quick and easy. And yeah. Large crane did 2.2 times 10 to the 4 joules of work in lifting a demolition ball vertical distance of 9.5 meters. Calculate the average force exerted by the chain of the crane on the demolition ball. Okay, so we're looking for average force. So this is only for 3 variables, so it's very easy to change. Work equals force times distance, divide by distance. You now have your force. So you have 2.2 times 10 to the 4 joules of work, a vertical distance of 9.5 meters. There you go. So you just go equals, because you know, eventually you'll notice that I skip a lot of steps when I'm reorganized. It's like, oh, okay, I just divide by this and I cancel over here. So I just ignore it. If you guys want me to continue showing this, each and every step of doing this, of like the canceling and manipulating, tell me. Otherwise, I will just do what I just did, which is just ignore this D down here. It's just like, oh, okay, move it over there. I know what's going on. So my force, I was back to the question, force equals work, which is 2.2 times 10 to the 4 joules over 9.5 meters. Then equals 9.5. It's a bit of a painful number. Okay, so I only want 2. I want 2 because there's 2 there and there's 2 there, so I just have to leave it to 2. So it's going to be 2.3 times 10 to the 3 newtons. Oh, that's what I got then too. Ooh, 2.3 times 1, 2, 3. 2.2 times 10 to the power 4. Divided by 9.5. No, it should be 10 to the 3. Whatever. 10 to the 4. Anyways, it should, I don't know, you guys can tell me differently. The calculation, it comes out basically the same. It's just, for some reason, I'm getting 10 times more in this one. I don't really know why. Anyways, so that is it. Just nice, quick, easy. I don't really have anything else. So, yeah. Hope you guys like it. So, smack that like button and keep doing what you want to do. Keep having fun. If you want to watch this, watch it. If you don't, don't. Totally respect that. Anyways, like I said, thanks for watching, and talk to you guys later. Bye for now.